Hi everyone and welcome to the Advent of Python. So in this series of videos, we'll be solving the Advent of Code challenges using Python, while we go from the very basics to more intermediate concepts, and we will also be using some extra things that are not really needed to solve the challenges, but are a good excuse to learn different topics about Python. So here I will be solving the Advent of Code in a very basic way, going through many Python concepts incrementally, but if you want to see my actual Python solution, which is shorter and more complex, you can check this minute of here at the end of the video where I will show my actual code and I will briefly explain it without much detail. So as you can see, Python is a high level, so this means that it's more close to humans and not to the machine code. So this means also that it's easier to learn, and it was created around 30 years ago by Guido van Rossum. Also, it's a general purpose programming language, so this means that it can be used for many things, for example, to build websites, for machine learning, for data analysis, data visualization, but also for common tasks like creating folders, sending emails, and many other common tasks. So it's a very good programming language to know. So this is possible especially because it has a large community that is creating many libraries that you can import easily from internet. So you can name a common task and for sure there will be a library there doing exactly that same thing. Also, it's a dynamically typed language, so this means that we don't have to specify the type of the variable. We can create a variable with a type of a number, and then we can change this same variable to a string or to some other kind of variable, and it's garbage collected, so we don't have to allocate memory and then free those resources. This is made by Python itself. These two things make it less efficient than other programming languages like C, for example, but at the same time is easier to program. And nowadays, as computers are so fast and they have much memory than years ago, that has been one of the main reasons that many people has been adopting this language, and nowadays it's one of the more popular ones. In many projects, the bottleneck is no longer the computer and the time that it takes to run the task, but the people that have to think and develop these programs. The latest version of Python is Python 3, more exactly 3.11, but you can have 3.8, 3.9, 3.10, for example, and you won't have any problem. Okay, so let's see how to install Python in case you don't have it yet, and also we'll see how to prepare the setup. So in Windows, we can search download Python in Google, and the first link, this one, you can download it from here and then install it. Make sure that it's properly configured in the path of your system. So you can check for system variables or system properties, and here in environment variables, you can see your path, and you have to make sure that in the path variable, if you edit it, you have to make sure that at the end you have this path. So you will have probably the first folders differently, but at the end you need these two paths of here, Python 3.11 scripts and Python 3.11. So make sure that those ones are at the top of them. And sometimes it's possible that in Windows 11 there is some pre-installed Python libraries. It's better to uninstall all of them and then do a clean install and make sure that these paths are correct. Okay. If you are in Ubuntu Linux, you can follow these steps of here to install Python in your computer. Okay, so when we have Python installed in our computer, we can download Visual Studio Code. You can go and in a similar way, search download VS Code, Visual Studio Code, and the first link, it will bring you to the installer in your system. So Visual Studio Code is an IDE. It's a programming interface that brings many extensions and extra capabilities for programming, but it's not really a need. So just to make a little demo of the easiest way to run Python, we can open our notepad, the Windows notepad, which creates TXT files normally. So this is a plain text editor. It's not like Word, that it's enriched text. So here in plain text, we can create our programs, for example. So here we have a very basic example, two variables and adding them and printing the result. So we can save now this Python program with Ctrl S, and now what we have to do is save this, but not with the TXT extension, but with the Python extension. This, for example, we can save it in any folder that we know, and then we can go to the terminal. So I recommend you to install the Windows terminal if you are in Windows. So you can download it from the Microsoft Store, this one. Otherwise, you can use the PowerShell, which is quite good also, but this one is better. So in the Windows terminal, in PowerShell, we can go first to the desktop folder where we had that program. And from here, in order to run Python, if we have installed already, we can write Python and then the name of our script. And as you can see here, we can see this result of here, what we print. So this is a very simple way to write Python and run it. Even so, we will be using Visual Studio Code with Jupyter Notebooks, as we saw in the last video. Okay, so I created this folder of here, admin of Python. And the first thing that we will do as a good practice, I recommend you to do this, is to open the terminal here. We can open it from here or with the command that you will see here. And here we see again the PowerShell terminal, but now from Visual Studio Code. And it's already in our folder, our current folder that I created, admin of Python AOC 2022. You will need to install first Git also. I forgot to mention. So you can install Git in Windows, again, looking for download Git Windows, and then the first one, you will have here the instructions to install it in your system. In Ubuntu, it's already installed by default. Okay, so when we have Git installed, we can come to the terminal and write git init, and then we can rename the master branch as main. This is a recommended way to do it now with GitHub. And now we have our Git repository created in this folder of here. So now we will be able to track our change in files, and also we'll be able to push this folder of here into our GitHub repository. Okay, so let's start by creating a new Jupyter Notebook file. Let's create it the day one IPy notebook. This is the extension of the Jupyter Notebooks files. So before starting with the actual challenge, we will need to see some basic Python concepts. I will be introducing some concepts every day, but this first day I have to introduce quite much of them because in order to solve this first challenge, we need to see some of them. The next days I will try to only show between 1 and 3 concepts of Python, but today we'll have to see the basics of variables, operators, and then the for and while loops and if-else statements. So we'll see the basics of those. These are the minimum required tools of Python in order to start solving this challenge of today. Okay, so let's start with the variables. These are the basic variables in Python. So we have mainly 4 types of basic variables. Those are the integers, the floats, which are decimal numbers. Then we have the strings that can be a single character or multiple characters between quotes. They can be single or double quotes. And then we have the Boolean variables that are true or false with capital T or capital F. And then I introduce here also the concept of list, which are more complex variables, but they are very useful and we will be using them in our challenge of today. So lists in Python, opposite to other programming languages, they can have multiple variable types. So our list here, for example, has an integer, then in the second position has a float variable, then we have a string, and then finally we have not a value, but a reference of another variable. Okay, so now in our notebook, in order to make use of these variables, we'll need to run this cell of here. We can do this with Control Enter. Also, we will see here that the Jupyter Notebook and the Visual Studio Code is detecting our Python environment. We can change it here if we want some other one. For now, we'll use this one. So if you don't see here Python, maybe you don't have Python properly configured in your computer. Okay, so now we have run this cell of here, and these variables are loaded into the memory of the program. So we can program now new things, and the code will be run in parts, not entirely, but every cell will run independently of the other ones, sharing the same memory. Okay, so now that we have these variables in the memory of the program, we can see some interesting things about lists. So the list in Python has many methods, but one basic and that we will be using today is the method append. So we have here our list variable as we had it here. So now if we want to add more elements to our list, we can use the append command, and now we can add here any type of variable, even other list or any kind of object. So for example, let's introduce here now another string. Let's put cat, for example. Now in another cell with the V, I create new cells. Let's see the content. Okay, now we see here that we have our added element, this cat. We can also access to individual elements of the list. We have to do this with the index. So the index starts by 0. The first element has the index 0. The second one has the index 1. The third one has the index 3, and so on. So for example, if I want to access to this 2.3, this is the index 1 because this is the second element. If I put with the square brackets this index 1, I will get my second element of this list. The same way, if we want to change this element, now we can assign to our index 1 of this list, also with brackets. So we can assign to this list bar element index 1 another variable with, it can be the same type or another type, because as we said, it's dynamically typed. And we can put here now hello, for example. And now if we again print our list bar, we can see now that the second element, now it's not 2.3, it's hello. So these are the most interesting things about lists. We will see some other while we solve the challenge, but those are the basic ones. In Python also we do comments with a hashtag character, and then the next line following that hashtag, it will be all a comment. We see this in Visual Studio Code as green characters. This means that this is a comment, but it could be some other color. Okay, now the second concept that we will see now is the operators in Python. So these are the mathematical operators. So in this example, I put here A as 5 and B as 3 as examples of variables. They could be also float variables, and they will have a very similar behavior. So now if we run this entire cell to see every one of those, okay, so we can start with the addition, with the plus sign. We can add subvariables, we can subtract them, we can multiply them, we can see here the results, we can divide them. And now the most interesting ones are the floor division and the modulus, because they allow us to round our division, so have an integer, not a float as a result. And also the modulus is the remainder of the division, so we can have the remainder like this. This will be useful for some other advanced concepts later. We also have the exponent operand with double asterisks. Then we have another type of operators. Those are also operators, but those are logical operators. So they return true or false only. They compare the left and the right variables that they have, and depending on the comparison, they will return true or false. So here we have the equals. It's a double equal character, then the not equal, then we have the greater than or equal to, smaller than or equal to. We can run them to see them better. So again, we have A as 5 and B as 3. So A equal to B is false. A not equal to B is true because 3 is not 5. Then we have yes, so 5 is greater than 3. So here we can see this true. Then we have yes, 5 is greater than or equal to 3 again, this true of here. Then the same with less than and less than or equal to. So those are the comparison operators. Okay, so now we'll see the third concept of Python today, and these are for and while loops. So in general, if we can choose, for loops are better, and here we can see how are for loops in Python. So this is the most classical way of doing for loops in Python. It's a little bit different compared to other programming languages, because here we don't have to declare a variable, for example, I, an iterator over a series of numbers. So we don't have to declare the typical I equal to 0, I smaller than something, and I plus plus, for example. In Python, the for loops iterate over an iterator that is called, for example, a list is an iterator. We have elements and we can iterate over them. A string is also an iterator. So any element in Python that is an iterator, we can iterate it over in a for loop. We can see here an example. So we have our list of fruits with these 4 fruits of here, and we can declare it like this for fruit in fruits. So fruit will be every one of these fruits at every loop of our for loop. So in every for loop here, we will be printing our fruit. We can see here apple, orange, strawberry. So every one of those in every single loop, we access it with this fruit variable. Even so, we can also do the classic for loop iterating through the index of the list. We can see here an example to do this. Range can take a single argument, 2 or 3. So if we only introduce 1, it's the limit of the range. It will go up to 5 without including 5. We can see it here better. And we have to create a list of it because range is only an iterator. We then need to create a list to see it or iterate it through a for loop. So here range of 5 creates starting from 0 up to 5 without including 5. We have here a list of elements. Then if we add a second element, the first one, then we will start from this element. For example, here we don't start now at 0, we start at 1. So this is the start and this is the stop. And if we add a third element, this is the step. So now it will go every 2 numbers. We can see it here better. So it goes from 1 to 5 without including 5 every 2 numbers. Maybe we can see this better if we go up to 20, starting at 5 every 3 numbers, for example. So here we are starting at 5, we go every 3 numbers, and up to 20 without including 20. So this is the range command. Usually we use it with only a single number. As we said, this is starting from 0 up to 5, going with steps of 1. So here what we are doing is the same, but with the fruits list, with the command length. We can see it here better. So the command length of our list fruits, for example, So we have 4 elements in our list, and we can see here that it returns the length of this list. So 4, because we have 4 elements. So this will be equal as putting here simply 4, but now if we add more elements in our list, this will be a larger number. So we don't have to update the length of the list in 2 places. We will have it always correct. So now with this way of doing for loops here, I won't be an element of the list, but it will be an index from 0 to the number of the length of the list. Here we'll be printing this index to see it better, and then accessing this element of the list with the index as we saw it before. So let's print this, and yes, so we are printing 0 first because we are starting the range from 0, and then we are accessing the 0 index element of that fruits list, which is apple. Then we have the index 1 at the next loop. So here we are starting the second loop of the for loop, and we are accessing the index 1 of this list. It's orange, and so on. And then in Python, we also have while loops, as we can see here. So if we need it, we can also have while loops. While loops are declared like this with the while command. We have to declare now the variable outside of it. In contrast to for loops, now we here have to declare the x variable in this case, or whatever that is the variable. And while this condition of here is true, we'll be doing loops of this command. So one very important thing here is that this condition of here at some point has to be false, because otherwise we'll be doing loops forever here, and we'll have to stop manually our process. Otherwise, this will be running forever. So in this very basic example of here, we are starting x as 0. We are adding 1 to x. So this is the same as doing x equals to x plus 1. And then we are printing x. Let's see it. So we are doing this very basic example, but this could be anything more complex that you would need. Finally, we'll see our fourth and last concept before starting the competition. And these are if, elif, and else statements. So let's see them. So here we have 3 examples of them, starting with the most basic one, only an if. So in the if case, we have to write if here and then something with a condition. So if this is true, the next line that has to be indented. So in Python, we don't do brackets, we do blocks with indentation levels. So in this case, if this is true, this block of here, the next lines indented will be running, otherwise they won't. Let's see this. Let's put, if we have our animal dog and this condition is cat, this doesn't print anything, but if now we have here cat, so if our animal is really a cat, we can see here that it prints our meow. Then we can see this with else also, if and else. So now the first one will be false, and then it will go to the next one. So if this was true, run this, but in any other case, run this line of here. So now as we have cat, so our animal is not a dog, else write this of here. If we had a dog here now, let's try it. And now this of here will write the first line. It runs this first line, but not this one, because we are here, we print this one of here. And then we cannot also elif, so we can go first to this first statement of here, and if this is not true, we can check this one of here and otherwise run this one. We can have here as many elifs as we want, so we can have here multiple of them. And finally, an else statement if we want to print something else, if these of here are not fulfilled. Now we can check this with dog, for example. So we are going here, okay, it's not a bird, and we are going here, but it's true that it's a dog, so we are printing here and then not this line of here. Okay, so this is more or less the basic concept that we had to see about Python. Now we can start with the actual challenge. Let's start here another cell with the challenge. Okay, so let's go to the day 1 of the Advent of Code challenge. And this year, it seems that the story will be around the reindeers of Santas, and they need some magical energy. So the elves will have to go through a jungle, and they will have to achieve some snacks. And to cross the jungle, they have some inventory of supplies, but it seems that some elves have lots of supplies and some others have less supplies, so they decide to write a list with the supplies of each one. So this is a short one, our real input will be larger. But basically here they write every supply of every elf in every line. And if we have a blank line here, this means that this is another elf. So these 3 of here are one elf. This 4,000 of here is an elf with a single supply. Then this is the third elf with 2 supplies, and this is 3. And the number is the number of calories of each supply. So we will have to add them. So to know the first elf, how many calories he has in supplies, we'll have to sum them. So 1000 plus 2000 plus 3000, it's 6000 calories. This is the number of calories of this elf, and so on. The question of today, the challenge, is to know which is the elf with the largest number of calories, and the answer is this number of calories. So we'll need to go through this list, summing all the supplies of each elf and looking for the largest one. Okay, so let's go to the real puzzle input here, and this is the real one. We can see that it's a much larger list of here. Okay, so now we have to do the Control A to select all numbers until the last one, and then Control C. Now we could go into our Jupyter notebooks and create the variable, and then we saw this way of doing strings. These are a single line strings, and if we want to do multiple line strings, we can create them with a triple quote, triple double quote, and here we can put any string, a single line or multiple lines. This could be an example. We can print this to see it better. Okay, we have here the new line character. So this is the raw string, but if we print it, the print command will print it better. Now we see this. So we can create multiple line strings with this triple quote. So we'll need our input in this format. But now if I paste here our input, let's try it. Okay, the thing is that this will work, but it's so large that it's almost filling all our notebook. So this would be the more basic way to do it, but we'll do it in a simple way. It's a little bit more advanced, but it's the way that we saw it in the last video. So we'll create in our project a data input folder, and here we will create a new file inside the folder. Make sure that this file is inside the folder and not in the general one. And this file will be called day1 input.txt, the text format. And here we'll be pasting our input, and now we can save it and close it. Okay, we have it here. So as we saw it in the other video, the way to access now to our input row is with the with command open. So we'll be opening this file. I will explain better what this with means and the open and so, but for now just use it, and you have to understand that this is in order to access to this text file and extract our raw content of it, our string, our input. So we have to put here now the path to this file relative to our current file. We are in the day01 IPy notebook file, and we want to access to this one. So this is inside the data inputs and then the name of the file. So slash in our current folder, data inputs folder, and then inside that folder, we want to go to the day1 input.txt. Okay, this is the path to our input file. We will call this file as f. We can put here any name. Let's put f of file to simplify it. And now our input row will be equal to, this file has a method that it's read. It will simply copy the content of this file to our input row variable. Let's try it, and we'll be printing it here. Okay, I have a typo here. Now it works. Okay, so we can see here now that we have our string. It's so large that it's not fully printed, but we can see it. We can now also do it as before. If we print it like this, now we can see it in a row format, and we can see now that our new line separator, so between every number, so we can see here the two first numbers, and we can see here that in a row format, we have this /n, this new line character. So we'll be using this to know the calories of each snack. So every separator of this indicates that it's a new snack. But in order to differentiate snacks from different elves, we see here that we have this blank line, and this blank line is basically this one of here. So these are two new line characters. So if we have a single one, this indicates a new snack from the same elf. But if we have two together, this means this is a new elf. Okay, let's delete this now to make some space. Also, we don't need this one now. So in a new cell, now what we have to do is we have this raw string, and we have to separate it into lists. A general one and outer one that will be a list of elves. So we want to have the first elf, then the second elf, then the third elf as elements of this list. And the elements of this list will be other lists of snacks. So we'll have a single general list of elves, and the elements of this list will be lists of snacks of each of the elves. So as we said, a list can have any type of variable. So lists can have lists inside them. Let's see this with a very simple example, just in case it's not clear. So we can have a list, a normal list of integers, could be this one, for example, and then we can have a list that is englobing this other list. So this will be one list that has only one element, and this element is a list with 3 numbers. Let's print it. So now if we access to the first element of this list is our internal list. Okay, let's delete this to see it better. Now we have single squares. And if I do the first step, we can see that we have double square brackets. So we have one list inside another list. Now here I can add another list. It can be a list with, again, with any type of variables. If I print now this, we have one list with 2 elements. Every element is another list with other elements. This seems difficult, but this is the way that we'll be building our list of elves. So every element of the larger list will be an elf, and every elf will be a list with the snacks of this elf. Okay, so in order to do this, we have seen that every new line is separated by a /n, and every elf is separated by 2 /n's, so 2 new line characters. So in order to have our list of lists, we could do it looking at our input row. So it's a string, and a string is actually an iterator, not a list, but similar to a list of characters. So we could iterate with a for loop over all characters, looking for these /n characters, and then putting every integer in a string format in a separate list, and then finding the 2 new line characters and putting the previous ones in a separate list. We could do this, but this would be like quite long. It would be a good practice for loops and basic Python concepts, but luckily in Python we have a command that it's called split. So the split command, what it does, we can see it with a more simple example. So imagine that we have this text of here that I copy and paste it. So okay, we have this text of here, and we want a list of the words of this text. So this is now a single string, and we want a list with every word as an element. So we have these spaces of here. So our split command, what it does, we can call this as text, for example. And if we have this text, we can apply here the split command, that it's a method of the strings of Python. And now we can put here the separator, that will be this blank space. And now if we execute this, this creates our list, splitting our string with this separator. So at every place where there is a space in our string, it will remove it in this case, and it will create a new element of the list until it gets the new one. So we can see here ipsum is the second one, and the spaces are not here. So we can do the same thing, but in our case, it's not a space, it's the new line character. So we'll create this elves list, and this elves list will be our input row with a split of the 2 new line characters, because we said that our elves are separated by 2 new line characters. So now we want the outermost case. Then we'll separate every snack inside every elf, but for now we need to go to the more general case, which are separated with 2 new line characters, as we said. So now if we do this, let's see what is the elf list. Okay, so we can see now that we have every list of snacks of every elf separated in different elements of our list with commas. We can see it here. Okay, now we have our elves, and now we need to separate the numbers, the calories of every snack of our elves. But it will be better if we call this elf list as preprocessed, because we will need to create a new one later that will be the final elf list. And now that we have our elf list, let's run this again. Now we need a for loop for elf in this elves list preprocessed. So now we'll need to separate every snack in one of these lists of snacks with the new line character, the single one. And we will create the final elf list that we'll prepare here as an empty list. So now for every elf, we'll append our elf with the split command with the new line character. So let's see what this does. Let's take, before running this, so we have our elves list as we saw it before. Let's take the first element, the first elf. So this is the first elf. So now we want to split it with these single new line characters. Let's test it. This is a good way to see if then this for loop will work or not. Let's split this first element with the new line character. As you see here, we can concatenate operations in Python. So we are here accessing to the first element, and from this first element we are applying this method. This works in Python, and sometimes if there are a few of them, it's good to do it. But now if we had here 5 more methods, then it will be very difficult to read. So it's good practice to not append many of those, but 1, 2, or 3 are okay. Let's run this, and we see here that now for every elf we are splitting every snack calories in another list. So this is what we wanted, and this is what we are doing here. For every elf in this elf list, we are splitting their snacks with a new line character. Okay, let's run this, and let's see now our final elves list, how it looks like. And we have here now our elf list with each elf having a list of each snacks. And we see here now that we have our number of calories, but this is a string number, not an integer, and we want it in the integer format. So as we saw before, now every number is not an integer that allows us to do mathematical operation, and then will allow us to do the sum of all snacks and see what is the largest one. But we have here a string variable. They are in single quotes, not in double quotes, but it's a string. So we have to transform every one of those string numbers into integer numbers. So the best way to have our calories list as integers is going back. When we created our list of elves, having every elf his list of snacks. So one simple way to do this with the Python concepts that we have seen so far is creating a snacks list. Our snacks list will be elf, what we have done here. So we'll have here now our list of snacks that will be these strings, and now we'll do a for loop for snack in our snack list, and we'll transform as integer snack, let's call it. The integer snack will be, this command will transform a string into an integer. So we want this snack as an integer snack. Let's see what does the integer command, this int command. So if we pass here a string, but it has to be a string of numbers, not of letters or any other character. If we introduce here a string, we see that it returns an integer. This string of here, if it were an integer, if it were a string, it will be printed with quotes. This is a string, but the other way with the integer method, we see here that it's an integer now. So this is what we are doing here. We are taking every one of these snacks of the snack list and transforming it into an integer. And now here we have our integer. So we'll create our new snacks list that will be of snacks integers, empty for now, and we'll be appending into this new snacks list, append this integer snack. Then finally we'll be able to introduce this new snacks list to our elf list. This can be a little bit complex. There are more simple but advanced ways to do this in Python. For now, this is a good exercise to see how for loops can be nested. So let's try this now and see what's the result. Okay, let's see what is now the elves list. And finally, we have our elf list. Every elf is a list of its snacks, but now in integers. Okay, so now that we have our input as we want it in this elf list, we can start the challenge. We put here a comment to separate the part 1 with the previous preprocessing steps of the input. So they are asking now to have the list of the total calories of each elf and then find which is the elf that has the most calories. And this will be the result of our first part of the challenge. So let's create first a list of the calories of each elf. Elf calories list, let's call it, will be empty for now. And then with a for loop, we can go through each elf and adding all the calories from every one of those. So for elf in our elves list, and we need to create here a variable for the calories. So calories will be empty. And now we need a new loop to go for every snack. Well, we call it snacks, but they are actually supplies. But anyway, for a snack in elf. And we'll be adding these snack calories to the total calories of each elf. So we'll be adding the snack calories to these total calories. And at the end of this loop of here, after finishing all the snacks of this elf, we can go and add these calories to the elf's calories list, append this calories value. And then we will go to the next elf. You can see here that after each elf, the calories is resetted at 0. So if we started this calories variable here, then it won't be resetted. So we'll be adding more and more calories. It will be the total calories of all elves at the end, but we need to put it here. So after each elf, it will be resetted. So put it back again at 0, and then we'll be adding only the calories for each elf. Okay, let's run this and see what we have. Let's print here the elf calories list. And so we have a list, and now it's not a list of lists of snacks, but it's a list of the calories of each elf. Okay, it looks good. So let's run it again and let's start a new cell. Now we need to know which is the largest one. So there is a Python command for this, but we'll do it in a more basic way. So let's find the max calories and let's put it at 0, which is the minimum because we don't have negative values. Okay, so let's create now a for loop for elf in our new elf's calories list. Okay, so now it's not the snacks of the elf, it's the total calories of this elf. Let's put better for elf calories. Let's put it like this. We'll be checking if this elf has the largest number of calories. So we'll be checking if our current max calories is smaller than our current elf calories. Then our current elf calories is the largest one. So it's our current maximum. Max calories now it's equal to elf calories. But if our current elf calories is not larger, so it's smaller than our max calories, we want to do nothing. So at the end of this, we'll have the elf with the maximum number of calories, and this was our result of our challenge. So we could print this as the result if it runs successfully. So result 1 will be this max calories that we'll have at the end. Let's print this and we have the result of here. Let's see what was my result today, and yeah, it was actually this one of here. Okay, so that was the first part. Let's go to the second one. Let's put here a new cell. Part 2 of the challenge. And now what they say, if you read here, is that they don't want only to know the maximum one, but the 3 maximum. So the top 3 that has the largest number of calories. So we can solve this second part in different ways. We could, for example, order our list. There are some methods to order lists in Python automatically. We could develop our own, but as we only need the 3 largest, and in order to order a list manually, you have to go many times through all elements of the list, and we only need the 3 maximum elements of our large list. I think that we shouldn't go through our entire list more than 3 times. So my way to do this will be, if we had, for example, this short list of here, let's put a basic example, and imagine that we want the 3 largest numbers of this list. So we can go like the first time looking for, as we did here, looking for the maximum and storing it. Okay, this is the maximum now, this is the maximum now, this is not, this is the maximum now. So we can go and we would find that 9 is the maximum. Okay, we can keep the index of this largest number, not only the value, but also the index. And at the end of this first loop, we can go and at this index where we find the maximum number, we can go and put here a 0, for example, and store the value of that 9. Then we can iterate for the second time and go through all numbers, finding the current maximum one, that will be 8 at this case. We will store this value and also the index, and we can go to this index and put this at 0. And finally, as the third time, we can go and find the 7 that will be the maximum at that moment, store the value and put the index at 0, but at that moment we would already have the 3 maximum numbers of that list. So I think that this would be the best way to do it without using more advanced methods and without spending more time ordering the entire list while we only want the 3 largest numbers. Okay, so in order to do this, we'll do it in a similar way as we had it before. So we want to know our maximum calories, but now we also want to know the index. Let's put I. Our index now will be none. So, okay, in Python, if we want to declare a variable but don't put any value, not an integer or a string or anything, we can put it as none. None means that, okay, we have this variable, we want to reserve it, but with a non-value. Our I cannot be 0 because there is the 0 index, but our maximum calories can be 0 because we don't have any 0 calories and it won't be the maximum at any case, so that won't be any problem. Okay, now we will do our for loop again as before for elf calories in elf's calories list. But now, as we'll be at every step deleting the maximum number, just in case to not lose any information, maybe we have to repeat it and then we won't have these 3 largest numbers. It's better to make a copy of this list. So let's create a elf's calories list copy. Let's call it like this. And this will be a copy of this list. So in order to do a copy, we have to copy it like this with this command, because otherwise it's not a real copy, it's a reference to, so we are assigning a reference to it. Let's do a quick example here. So imagine that we have our A, that it's a list, 1, 2, and 3, and we do B, that it's a copy of A. So B and A will be referenced to the same object in Python. So now if we go to B and we say, okay, the first element of B, I want to change it. So B now it's same as A, 1, 2, and 3. So, and now the first element I want to be a 5, for example, and we print here A and we print then B. We see that not only B was changed, so we were only changing the first value of B as 5. So both are changed, because here B, we are not creating a new copy of B, but we are assigning B as the same place in memory than A. So this is a tricky thing of Python. It has some of this concept that you have to be aware of. So for this reason, now if here instead of assigning B to A, we do a copy, this will create a real copy of it. So now if we run this again, we can see that the first one, that was our A list, has 1, 2, 3 the same way, but our B list only had this change of putting the first element as 5. Python is good for some things, but then it has these tricky things hidden that you have to be aware of. Okay, so now with this copy command, we won't lose our original list, and now we can delete elements of this list and come back again to our original list. So we have to go through our new copied list, and we wanted to find the max calories. If max calories is smaller than our elf calories, our current elf calories of our loop, we want our max calories to be our current elf calories. But now we also want to know our index. So there are some ways to do this in Python. Let's do it in the more simple way. So we can have the traditional index for loops. So we should use one of those now. So I have to change this for I, and I have to put here the range of the length of our elf calories copy list. So now I will be the index, the numbers. So now we will be able to track not only the max calories, but also the position of these calories in the list. Also, this won't be elf calories. This will be our elf calories list copy accessed by this index element. And again, this will be our current elf calories. Okay, so this is a little bit more complex than before, but now we don't only have the value of our current elf calories, but also its position, its index position in the list. So now we can put here our I, which is the position of our current maximum calories elf. I will be I, so we have to rename our I. So this cannot be I, it has to be max I. Let's put. Otherwise, it will be the same variable and it won't work. Max I is equal to I, okay. And now at the end of the loop, in a similar way of before, we'll end up with the elf with the maximum calories, so his total number of calories, and also his index position. So we want to store it into another variable that will be called the top 3 max calories. This will be our final result. So at the end of this loop, we want to add our current max calories. And we want to repeat this cycle 3 times. So now we want to do this in a for loop 3 times. Let's put for j in range 3. So as we said before, this will create 3 loops, because range 3 will make j to be 0, 1, and 2. And now we have to put this variable outside this larger loop. And now we'll be repeating this iteration of finding the current maximum value 3 times. What we have to do also at the end of every one of those loops is to eliminate from the elf calories list copy, to put this IELF, that is the current maximum calories elf, to put it as 0. So putting his calories at 0. So it won't be anymore the largest one. And then in the next loop, we'll go for the second one, and we'll be storing its number of calories in this variable. And in the third loop, we'll go for the third one. And every time we'll be putting their calories at 0, so they won't be anymore the largest one. Also, before running our 3 for loops, we also need to put this outside our loop. Otherwise, we won't really eliminate the largest one, because we will be creating the copy again every time. So we need to create the copy just once at first. Then at every loop, we'll be eliminating the largest one and without the copy. Now we also need to change something here, that is, this is not I, is max I. This was another error. So we want to replace with a 0 the total maximum I, not the latest one. That was what we were doing before then. So okay, now we already have the result. We can print here result 2 will be now our top 3 max calories. And this is the result, 203,420, the same number as I had today here. So let's do a recap of what we are doing here. So we are initializing here what will be the final variable, that is the total amount of the 3 elf with the maximum calories. So now to do this, instead of ordering our list or doing other things, for every loop of those, we will be storing here which is the current maximum number of calories and the index, to be able to then go at this position of the elf with the maximum calories and putting it to 0. So then it won't be no more the largest one, and iterating like this 3 times. Then we print the result and it's correct. Okay. So we haven't been using some more advanced concepts of Python that makes things simpler and easier, but we have been using today some of the most basic concepts to be more familiarized with the basics of Python. We'll be integrating more and more concepts and making it more complex, but at the same time simpler, our next solutions. And now I will show you how was my solution of the today's challenge, my actual solution. So here we have my actual repository, not the advent of Python, but my actual advent of code repository. And this is how today I solved the challenge using more advanced methods that allowed me to solve it in less lines of code, but more complex ones. So I will go fast through it. So first I was in the same way, opening our file and reading its content. Then, similar of what we've done before, I was using split with the double new line character. I'm separating first the elves list, the first list of lists, but then here with these 2 lines, I'm simplifying it quite much, because I'm using list comprehensions. So I'm using for loops inside the list. So I'm simplifying what we were doing before with 6 or 7 lines of code here in 2, because I don't have to create a new variable with an empty list and filling it at every iteration of the loop. Now I can do this step in a single line. This is more advanced to understand, but at the same time more simple. So you can do this if this line is not getting much long and complicated. Then for the part 1, I'm using map. Map goes through every element of the list and applies this function of here. So we have to put here a function and here an iterator that can be, for example, a list, and it will be applying this operation to every element of this list. Then I apply this max function that returns the maximum element of this map function. So this is an iterator. This is also an iterator that is applying this operation to every element of this list. So I'm taking the maximum of the result of this map. So here I'm summing up all snacks of every elf. And then here I'm taking the number of calories from the elf that has the maximum number of them. So this is the result of the part 1 in a single line. So it's more difficult to understand, but at the same time, it's more simple because it's a single line with only 2 elements nested. So this is still simple to understand. If now I need here to put more nested elements, this wouldn't be readable, and I should separate it in different lines as I had to do in the part 2, for example. So here, in order to get the top 3 elf with the largest number of calories, I created again this list of the sum of the snacks of every elf, because in the first part I didn't know that I would need it. And then I sorted this list. So here with this sort method of Python that I didn't want to use it before because it's not something very advanced, but I wanted to use more basic concepts for this first day of the challenge. So I didn't want to use this sort or this sum or the map method that is even more advanced. So I wanted to keep it more simple, but here using sort, I could sort our list, and then I can take the three first elements. Here, for example, I'm using slicing of list. That is something that we will be seeing in the next days. So now here, summing our top 3 calories of our ordered list, I can have the total aggregate values of our 3 elf with the largest number of calories. And this is my final result for today. So this was the way that I solved today. This is not the only way to solve it, of course. There are many other ways to solve it that are valid in Python, maybe with less lines but less readable, with more lines and more simple. So this is not the best option. For me, it's a good balance between complexity and simplicity, but yeah, there are many other ones. I hope that you enjoyed this first day, and let's see you tomorrow. Bye bye.